Okay, today we're going to look at plotting linear inequalities in a graph. Requires skills. Make sure you need basic rearranging, so you're making y the subject. This one's really straightforward. All you need to do is just add 3x to both sides, so you'll get y equals 3x plus 4. Also need to know how basic inequalities work. So here x is less than or equal to 3, and here x is greater than minus 4. And lastly, make sure you can plot basic graphs using y equals mx plus c. So quick example, here y equals 2x minus 3. That means you would have a y-intercept of minus 3 and a gradient of 2, which means every one square you go across, you will then go 2 squares up. Okay. As always, the notes and handouts we're working through today are attached in the description. So, the inequalities, we're going to start with the basic inequalities recap, basically getting used to how this notation works. So this is like a really shorthand way of saying that x can be between two numbers. So for this first image, you can see x is in between 2 and minus 2. Now here, if the circles are coloured in, that means x can take that value. So here, x can be 2 and x could also be minus 2. If instead it looks something like this, then it would be the exact same inequality, except x couldn't be exactly 2 and x also couldn't exactly be minus 2. So to write this down, we basically copy this notation. You always use a less than sign, so this is saying minus 2 is less than x, and x itself is smaller than or equal to 2. This one, same idea. Here x is between minus 1 and 3, but it cannot be minus 1 and it cannot be 3. So that means you would have two circles, but they wouldn't be coloured in. Okay. This one's pretty much the exact same as the first one. Can be 2, cannot be minus 2, and then just join them together. Last bit of an edge case. Here x can be bigger than or equal to 4, and smaller than or less than minus 4. The way you have to do this is you have to write it down as two separate inequalities. So you'd have to say x is greater or equal to 4, or x is less than or equal to minus 4. Okay, that we should know. Pushing on, I'm going to start with a really quick recap of finding equations of y equals mx plus c. So first of all, going through these, this form only really works if you have diagonal lines. If you have either horizontal or vertical lines, it's a fair bit simple. So if I'm looking at line number 2, I can see it goes through this 2 here, and that is an x coordinate, which means for equation number 2, the equation is just x equals 2. Looking the exact same thing for the third line, it's going through 4, that's a y coordinate, so that equation will be y equals 4. And then 1 and 4, these are both diagonal lines, so you will want to use y equals mx plus c. So here, y-intercept's minus 3, so it'll be y equals something with a minus 3 at the end. And if we go 1 square across, we go 1 square up, so therefore it's y equals 1x minus 3. We just write that as y equals x minus 3. Number 4, the same idea. Our cut is at plus 2, so it's going to be y equals something plus 2. And if I go 1 square along, I go 3 squares down. So it's y equals minus 3x plus 2. Okay, that we should know, that should be fairly straightforward. What I'm going to do, the first thing you're going to try is working through these 4 questions. Okay, so for each question, we've got 2 things to do. I'll go through the first one with you. You have to write each equation in this form, y equals mx plus c, and then once you've done that, you then need to plot the graph. Okay, so we're going to rearrange first, and then you can plot it. So question 1's quite easy. We're pretty much already in that form. However, you always want x first. So to make life a bit easier, you would write it as y equals minus 2x plus 4. And then the exact thing we were doing before. You know what its y cut is, and you know what the gradient is. Okay. Just looking ahead, when it comes to this equation, you've got 2y. You would want to halve the entire equation to then get y equals something. Okay, I'll let you try those, and I will go through the answers in 3, 2, 1, 0. Okay, first one, y equals minus 2x plus 4. You start at 4, 1 across, 2 down, 1 across, 2 down. So that means if you ignore my terrible line, that will look something like that. Question 2, we want y by itself. Opposite of plus x is minus x. So you'd rearrange that into y equals minus x minus 1. Keep in mind, you could have minus 1 minus x, but it's always easiest to have the x terms first. Here, y intercepts minus 1, so we're going to start here. The gradient is also minus 1, so 1 square across, 1 square down. Carry on that, and then we have enough points to put our line together. So these will all be straight lines, makes it a bit easier. Question 3. As again, we want to halve everything, so if you do that, y is going to be 3 over 2x, or 1.5x, and half of 2 is 1. So we start at 1. And every time we go 1 square across, we're going to go 1.5 squares up. So it looks something like that. There's a word of order this time. Then get your ruler and make sure it goes the whole way across the graph. Last one, 2x plus y equals 0. 2 steps here. First things first, get rid of the plus x. Opposite of plus x is minus x. And then halve the entire thing. So it's just y equals minus x plus 2. Notice here there is no y cut. If there is no y cut, that means it's basically plus 0. Okay, so we're starting at 0, and each time we go 1 square across, we go half a square down. Again, minus x over 2, that is the same as minus a half x. So 1 square across, half a square down. That gives us enough points to get our line together. Okay, so that was the basics. On to the main thing we're doing, and that is plotting inequalities. Okay, so I'm just going to go through this one question, and then you'll have these 4 or 5 questions to do. So, these questions pretty much always go up in exams, always the same format. You'll be given a bunch of inequalities, and have to plot them all together on the same graph. Okay? For the most part, the way it starts off with, you can just pretend, this works for the first step, that you just have equal signs. And you basically just want to start by plotting these lines. So that's what I'm going to do first. So first, y equals 3. We find the y-axis, we find where 3 is, and it's a straight line going through 3. Next, y equals minus x minus 1. Y cuts at minus 1, and if you go 1 square across, you go 1 square down. Again, get a few points, get your ruler, and then draw a straight line going through them. On to this one, we've got y minus 2x equals 3. We can't plot this yet, we need to rearrange it. We always want to have it y equals, so if I do that, I then get y equals opposite of minus 2x is plus 2x, so y equals 2x plus 3. Again, remembering keeping the x's at the front. Plotting this, y cut is 3, and it's 1 square across 2 squares up. Okay, that's enough for a line. If you're not sure what to do, rather than go 1 square across and 2 squares up, you can also go 1 square back and 2 squares down. Do the exact opposite if you want more points for your line. Either way how you do it, you should end up with these lines here. Okay. Now we look at the actual inequalities bit. Okay. Do that, I'm afraid, to get rid of this line temporarily. The way we plot these inequalities, first of all, if it can equal that number, if it can equal the equation, you've got an equal sign as well, like less than or equal, greater than or equal to, then it's a solid line. If it's just greater than, that means you want a dashed line. So I'm going to plot this line again, but this time I'm just going to do a dashed line. This basically says that you cannot be right on the line. It cannot equal the line, but it can be right next to it. Now I can actually shade the region. To do that, we're going to use what's down here. Whenever you've got a greater than sign, that means you're above the line. Whenever you have a less than sign, that means you're below the line. Here it does not matter if it's equal than or not equal to. So going through them, my first line, was y equals 3, and I want to be below this. So I'm going to make sure whenever I finish, I'm going to be below this line. Next, I've got a greater than, so I want to be above this line, because this line here was y equals minus x minus 1. And lastly, same way, I've got another greater than sign here, so I want to be above my dashed line as well. So if you combine those three regions together, the area that satisfies all of them is this little triangle here. And for these questions, normally like 9 times out of 10, you're going to have a little triangle. Occasionally you don't, but most times it's always a little triangle. Okay? That's the basic idea. Scrolling down, you've got a few questions to try. I'll give you a few seconds to do them. Feel free to pause the video, and then I'll go through the answers. So going through the answers in 3, 2, 1, 0. Okay, for this equation, you're told x is between 1 and minus 2, and it can't equal minus 2. So solid line, dashed line, y is greater than but not equal to minus 2, which again means a dashed line. And y is less than x plus 1. Again, that's going to be a dashed line. I'll do that in blue just so it's clear to see. And that's going to look like that. If you combine all the inequalities together, we're going to end up with not quite a triangle, but near enough, this little shape here. Okay, next one, exactly the same idea. Y is less than or equal to 5. That can equal 5, so I want a solid line going through 5 here. Y is greater than 7 minus x. I'm going to quickly rewrite that as minus x plus 7. So the y cut is 7, and it's 1 across and 1 down. Okay, just get a ruler for that. Again, that's also a solid line because it can equal this. And lastly, it can equal this as well. That's going to be x minus 4. So it starts at minus 4, 1 across and 1 up. Okay, and that should look something like that. Okay, now I need to work out the region. I want to be below this line, so underneath the red line and above the two blue lines. So again, it's going to be this little triangle here. Next one, we've got a part B here that I'll come to in a second. First of all, the inequality. X is greater than or equal to 2. Solid line is equal to it, and we go for the x coordinate. Y is greater than or equals to x. So I need to plot y equals x. That's just a straight line going from the origin. Again, because it can equal it, it's going to be a solid line. Lastly, x plus y equals 6. I'm going to rearrange that, and I want to plot y equals minus x plus 6. Again, plus x goes to minus x. So here we're starting at 6, and it's 1 across and 1 down. Okay, so we've got those three lines. We want x to be greater than 2, so we can't really be above this line, but it's greater than 2 is quite obvious. It can look like that. And we want to be above this line, but below this line, and again, it's that little triangle there. Lastly, part B. We are told the point P lies inside the region. X and Y are integers. Integers, just as a recap, that means whole numbers. And we want to write down the coordinates of all points which are in this region, which have whole number points. And that is just these 1, 2, 3, 4 points. So you would just write them all down. 2, 2, 3, 3, 2, 3, and 2, 4. Okay, last one's a bit different. We want to write the inequalities satisfied by the shaded region. So I want to be below this line. Obviously all lines are solid, so it's always going to be equal sign for the inequalities. I want to be below this line. So I want to do y equals mx plus c here. My y cut is 4. And if I go 1 across, I go 1 down. So it's y equals minus x plus 4. That's the equation of the line. Because I'm below that, my inequality is that y is going to be less than or equal to that. Lastly, I want to be above 0 for my x and my y coordinates. So I need to say that x is greater or equal to 0, and so is y. Okay, fairly straightforward. Same idea with this one. And I'll start with the diagonal line again. So y equals mx plus c again. This one's really straightforward, and it's just y equals x. I want to be below it, so my inequality is y is less than or equal to x. I've then got the two straight lines. This straight line here, so y is going through the y coordinate of 2, and I'm above it, so it's y is greater than or equal to 2. Here it's going through the x coordinate of 5, and it's less than it, so it's going to be x is less than or equal to 5. Okay, that's it. That's the basics of plotting linear inequalities. The following lesson from this, we're looking at quadratic inequalities, with the same idea, just a tiny bit harder. Okay, thank you for listening.